Hi, everybody. It's Rufa. So the recording from our session, it looks like it didn't save properly. So I'm going to go ahead and make this video for you to post so that you have the notes and what we went over. Really quick, one of the questions that we had during our session was, how are we going to review for the AP exam? So this semester is the only time that we have this class. You're not taking it for the year. It's a year-long class that we're crushing into one semester because we have block schedule. So that means we're going to have to move at a faster pace. But we are going to have study sessions in the spring. So in the spring, we're going to have some Google Meets scheduled, probably weekly, every other week to start maybe, and then weekly as we get closer to the exam. The exam date is May 5th for AP Physics, and we're likely going to do study sessions maybe during the advisory period during the week. So we'll send out a form as that gets closer so that we can decide on what day works for everybody once we get into that semester. So if you need extra support, we'll still have Google Classroom open. We'll still be doing some meetings and study sessions to help you prepare for that exam. Okay, so I want to get into some math review for this class. Physics is algebra based and calculus based. This is going to be an algebra based class. Some understanding of calculus will give you a little bit of an edge, maybe, or this class will give you more of an edge in calculus, really. But you do need to know algebra. You need to be comfortable with it. So make sure that you are reviewing things. If we're going through this and you're like, I don't know, man, maybe you need to study up on it a bit more. Maybe you just need to practice more as we go along. Or maybe you need to consider a different class and take some more math and then come back and see me again next year. Okay. All right. So here we go. Math review. Going full screen. Come on, Google. There we go. All right. So topics today, and we're going to go through these as quickly as we can. But again, good idea to review these if you're feeling stuck and I haven't seen this before. So we'll go through measurement and error, SI units, scientific notation, slope, and algebra. Okay, accuracy versus precision. I'm gonna move my little widget up here out of the way. All right, so accuracy is how close you are to the correct value, okay? So on a target, that would look like clustering all of your shots near the bullseye. So that would be accurate. How close are you to the bullseye, to that number that you expect that is correct? Then precision is how exact the measurement is. So low precision would be like your darts are scattered all over the board, and high precision would be your darts are all clustered together in one area. When we have high accuracy and high precision, we have tightly clustered data right there at the bullseye, right there on the target. Okay. Uncertainty is the margin of error of a measurement. Now, accuracy and precision and uncertainty are really important in any science, but especially physics, where we're trying to measure things that are either really big or really small, especially the really small. If we have just a little bit of error, our precision could be, way off. Maybe if our lab equipment isn't set up right, we could have, our precision might not be so great. It might be all over the place. Our accuracy could be way off, but we have high precision if, we're not measuring things the right way, or if maybe our idea of the correct value isn't really correct and it's all the way over here instead of on the bullseye. So this is an important thing for the sciences. All right, moving along. Clicky screen. There we go. After looking at percent error, accuracy and precision can be understood a little more deeply, okay? Accuracy is how close you are to that accepted value. Precision is how reproducible your results are. That is, can you repeat that experiment and get the same results? So all of your values should be within the same margin of error if you've done a good experiment. So we want both good accuracy and high precision. Okay. Calculating error is something you're going to have to do a lot of in this class. So in science, it's always important to calculate your error in order to see if your results are significant. See how much uncertainty there is in your measurement and in your data. So our percent error formula, we have a theoretical value, which is what the actual number should be. And then we have our experimental value, which is the number that you got in your experiment. So percent error can be calculated by taking the absolute value of the theoretical minus the experimental divided by the theoretical, and then multiplying by 100. So you should get some positive percentage, okay? If your percent error is very small, that's good. That means you don't have a lot of error. Your data is solid, it's good. If you have a really big percent error and it's closer to 100, that's bad. You're not going to get counted off in labs and assignments and stuff. That just means that your data is not as close as it should be to the actual value. Okay, that usually means that maybe something was wrong in how you measured something or how you set up your lab. Maybe you weren't careful enough. Maybe you were, but you were using tools that weren't very good. Okay. All right, we measure all units in SI units. So this is known as the metric system. And everything we do in AP Physics is going to be in SI units. So that means we don't use feet and inches and pounds. We use meters. We use seconds. Okay. So we're going to have to become familiar with the standard SI units, metric prefixes, and their exponential factors. So here are our standard SI units that we're going to use in physics this year. For time, we use the second. For mass, we use the kilogram. And for length, we use the meter. So these are our three basic building blocks, or three basic SI units. Oh, my tablet just, there we go. So these are our three basic units. And we want to make sure that we are doing everything in these units. There we go, I fixed it. So no hours unless a problem asks for hours, okay? And the cool thing about these is that almost every unit that we will use in physics can be broken down into these. So these are basic building block units, okay? These are our metric prefixes. So these tell us the order of magnitude. They tell us how big or how small a number is. So you would put these prefixes in front of your SI unit. So for example, we might have megameters. That'd be 10 to the 6 meters. We might have centimeters. That'd be 10 to the negative 2 meters. We might have milligrams. That'd be 10 to the negative 3 grams. And nice thing is that AP has provided you with a handy dandy equation sheet, and you'll get to use this on the AP exam. But you also get to use this in this class whenever you want, whether it's a test or quiz or doesn't matter. I will put the PDF on Google Classroom, and you will also be getting a nice laminated, colorful copy for you to use. Remote students, I'll be putting that for you. I think they're distributed on Mondays, and I'll let you know when they're ready for pickup. Okay. In-person students, you'll be getting these whenever I come back. So remember, I broke my ankle. It'll be a bit, hopefully next week, but we'll see. So anyway, on the back of this card, you have you probably can't see that very well, but you have a metric prefix cheat sheet. So those are on there. All the common ones that you would need are on there, so that you can use those on the exam. Okay, so metric conversions. Just a quick example. We'll probably just do one of these. So if you need to review, say, exponential math, like how to do math with exponents, because that's one way of doing these conversions, there's a good review from Khan Academy. There's an article that you can click on. I've linked it in the slides, so you can follow along with that if you want to. But another way there are two other ways to do this. You could use dimensional analysis if you've done that in chemistry and you're comfortable with that, or you could do the decimal hopping trick. So let me pull up my drawing tools here. And decimal hopping trick is pretty easy. So we're going to try number 1. It says convert 345 millimeters to meters. So I know there are 1,000 millimeters in 1 meter. So that means there are 3 zeros here, 1,000 millimeters in 1 meter. So there are 3 zeros here. So I can do this decimal hopping trick. And there's always an invisible decimal at the end of every number, unless you already see one. So you can take your decimal and you can hop it over 3. 1, 2, 1, 2, 3. So now my new decimal is here. So that is 0.345 meters. Okay. So there's a quick little overview of those for you. And when we do multiple unit conversions, it's always handy to do dimensional analysis. So this one, 32 meters per second into kilometers per hour, you may have to convert a lot between meters per second and kilometers per hour. So here's a really quick review of dimensional analysis for you. So I have 32 meters per second. And the idea is I want to get rid of the meter and the second. I want to cancel them out. So in order to cancel things out, you need them on the opposite side of your fraction. So I know that I need seconds here for it to cancel and hours here. And I need meters down here and kilometers up here. So number of seconds in an hour, there are 3,600 seconds in 1 hour. And number of kilometers in a meter, there's 1 kilometer in 1,000 meters. Okay, so I can go ahead and cancel some things out this way. Seconds, seconds, meters, meters, and that should leave me with something in kilometers per hour. So I'm going to multiply 32 times 3,600 and then divide by 1,000. So that gives me 115.2, sorry about that, kilometers per hour. Okay. All right, moving on. Another quick trick, which is pretty cool. We're going to have to do conversions between meters per second and kilometers per hour kind of regularly. So let the slide load. We have the super duper speedy conversion trick number. It's 3.6. So if you remember the number 3.6, you're good to go. Okay. Oh, hey, there are drawing tools in here that I can use. That is cool. So the special number 3.6, that's a number that we want to use. So for the last problem, we were converting 32 meters per second, and we wanted to find kilometers per hour. So we're going to do 32 times 3.6. It's our magic number. And that still gets us 115.2 kilometers per hour. Pretty cool. Yeah. All right, let's see. Oh, no, that's not an eraser. That's an eraser. There we go. Maybe we'll see if it'll go away if we go to the next slide. Oh, no, it doesn't. Okay. I got to play around with these tools a little more. We're going to get rid of this for you so that it's not... Oh, there we go. Wipe screen. Cool. Okay, figuring out the technology here. Another quick problem solving note. All right. Always answer a question in the SI base units, so meters, seconds, kilograms, unless you are asked otherwise. Okay. So say the question gives you kilometers and hours. You should convert those to meters and seconds first before you do your calculations, before you provide an answer. Okay. So that's typical of what you'd be expected to do for this class. All right. Scientific notation. Scientific notation is important in physics because we're often working with really big numbers or really tiny numbers. And if you look down at this number here, this number 4, 3, and all those zeros, that's a really big number, and it's hard to see right away how many zeros there are without sitting here and going 1, 2, 3, 4, and so on. And so it can be really easy to lose a zero or to gain one. And then you're off by a factor of 10, and that's a big deal. So we like to use scientific notation, and this value over here is an example of scientific notation. It's shorter, it's easier to write, it's easier to immediately see how big the number is too. So a way that we convert these, we'll go on to the next slide for that. Okay, boop, boop, there we go. The way that we convert between these is we want to make sure that there's only one value on the left of the number. And then we want to make sure that we are counting the number of spaces that we move. So we're going to use that decimal hopping trick. So if you look down here at the bottom at number 1, we have this decimal right here, and we're going to move it 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, because we want to make sure that there is one number on the left of the decimal. So that would give us 4.83 times 10 to the, and because we're moving to the right, because we have a tiny number, it's going to be a negative exponent. So we have times 10 to the negative, and we counted 11 spaces. So times 10 to the negative 11. Okay, so that's that number. All right, let me erase that. And then for number 2 here, that's a number 2. It's not 2.89 something, it's just the number 2. Okay, for number 2 here, we have a really big number. And so again, we always have a decimal at the end of every number there, an invisible decimal. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 8.9 times 10 to the positive 13. Okay. Let's clear that out. Oop. There we are. And move on to the next one. All right, so graphing, quick review. You guys should know what independent and dependent variables are. If you don't remember or you don't know, please look it up. The independent variable always goes on the x-axis, which is going to be your horizontal axis. So independent variable always goes down here, and your dependent variable always goes on the y-axis, which is the vertical axis. Okay, so we have independent down here. We have dependent over here. All right. Pardon my awful handwriting. So make sure you label your axes, have good scale units, plot your points. When you draw a best fit line, do not connect the dots. Okay. Usually when we have a bunch of data, so let's say we've got a bunch of data points here, you're not going to connect the dots to get your best fit line. What you want to do to get your best fit line is try and get your line as close to all the points as possible. So that might look like this. Okay, again, you're not going to connect the dots. We don't want to do that when we're doing a best fit line. Okay, so let's get rid of that. Oop, don't want to get rid of that. Going back. Okay. All right, so slope is important too. You're going to have to use this for your PyLab at the end of the week. So slope is, the formula for it is y equals mx plus b. And you're going to want the slope of your best fit line, not the slope between two of your data points. So make sure you're finding points on your best fit line, not using two data points. Okay, points on your best fit line. M is your slope. B is your y-intercept, so that would be where your line intersects the y-axis here. Okay. Oh, that's cool. We got a highlighter pointer. Nice, nice, nice. Focus, highlight. Cool. All right. And then your slope can also be seen as your rise over your run, or your change in y divided by your change in x. So again, you're going to find 2 points on your line, and you're going to use your final y minus your initial y divided by your final x minus your initial x, and that will give you your slope. Okay. And finally, we have some algebra review here. You need to have strong algebra skills to do well in physics. Again, math is the language of physics, and it takes time to become fluent. It takes time to learn that language. Okay? So when you're solving a problem, you should always solve for the unknown variable algebraically first. Don't plug in your numbers right away. Solve for the variable first, then plug in your numbers. Okay, so we're going to do some practice whiteboarding here. I'm just going to do a couple of these just to help you out. So first one here, F equals ma. This is a common equation that you're going to see a lot once we get into forces, and then forever after then, because it's super important. So we're solving for A. So F equals ma. We want to get the A by itself. So how do we do that? We have to get rid of this m. And to get rid of something, you need to divide it by itself. And we remember in algebra, we have to do something to both sides of the equation. So anytime we do something, we have to do it to both sides of the equation. So I have F over m equals ma over m. These two m's cancel. And that leaves us with F over m equal to A. So I've solved for A, and now I can put in whatever numbers I want to for F and m. I'm going to erase that, and we'll move on to the next one. Okay, let's do E equals mc squared. We're solving for C. Okay, so we have E equals mc squared. And I got to get that m out of there. The m would be the easiest thing to get rid of. Good idea with algebra, with this equation manipulation, is to think about your order of operations. And you kind of go in reverse order when you're trying to solve for things. So exponents last. So we're going to go ahead and divide this by m to get rid of it. I'm going to keep changing the colors so that you can see what I'm doing. So the m's cancel, and then we have E over m equal to c squared. Okay. And now I want to get that c by itself. So just to remind you, the way we cancel out a square is to do a square root. So we're going to do square root on both sides. And that square root cancels out our square. So we have square root of E over m equal to c. And that's our final equation. Erasing that one and moving on here. Last one we're going to do is this one. It's another equation we're going to see a lot of when we do projectile motion. So that's moving objects and throwing things and rockets and stuff. So we've got vf squared equal to v naught squared plus 2ad. Solve for d. Okay, so I'm going to go ahead and write this up here. Vf squared equal v naught squared plus 2ad. Okay, we can think of this, anything that's added, we can think about it in separate terms. So v naught squared is a term, 2ad is its own separate term. So I can think about this v naught squared as a separate thing. So to get rid of it, to get rid of something that's added, you need to subtract it. So I'm going to do vf squared minus v naught squared equal to 2ad. Not bad. Now we need to get rid of that 2a from d. So we're going to divide by 2a. Oop, oop. We're going to divide by 2a, and on the other side by 2a. Cancel out the 2a there, and now we have vf squared minus v naught squared over 2a is equal to d, and that is our final equation. See if I can circle it there. Oop. All right, so that's the sort of algebra you're expected to know for this class. Again, if you need help, ask. Khan Academy has really good algebra review videos, so I also recommend checking out Khan Academy. Okay, I'm going to erase this, and that's about all I have for you. Again, this week is just math review and playing around with that online lab, so make sure that you are spending the time to do that. Hopefully it's review for a lot of you, but it's always good to practice and get back into the habit of doing this sort of thing again. Okay, so you got any questions? Email me. I will do my best to answer them. And I hope you guys have a good week. Looking forward to the semester. Bye. Trying to turn the thing off. There we go. Click.